Folks, so I have the pleasure of introducing our next speaker, Axelle. She is Principal Security Researcher at Fortinet, and she's well known in the community for reverse engineering and r2ai. And today she's going to talk a little bit about the use of LLMs and how that's kind of evolving reverse engineering, I think would be fair to say. So I won't do any more introductions. I will just hand over to you.
Thank you very much. So yeah, the introduction has mostly already been done. It's my first time in Norway, my first time, of course, besides Christiansen, but I'm really excited. And what is really cool is, well, if you have any question at the end, of course, feel free to come and talk to me in English, because I only picked up like 3 words yet. So it's going to be like a little bit difficult otherwise. And my daily job is to work on malware, okay? So I reverse them to detect them. There are many malware, so I'm only focusing on those which are for mobile phones, Android or iOS, and on IoT malware, okay, those. And with regards to IoT, I am the founder in France of the Phone CTF, which is Capture the Flag, which is dedicated to smart devices, so smartphones, connected objects, and things like that. So this talk has the buzzword of artificial intelligence in it. For some of you, it attracts people. For some others, it have them run off. So for those of you who were trying to run off, I can just say that I'm also going to talk very much about malware. So it will also discuss how to reverse malware and how we can do it faster or not with artificial intelligence. And the thing I learned actually yesterday was that actually it seems that in Norwegian, AI translates basically to KI. So if you see AI, you can say KI, kunstig intelligence, I guess. So yeah, that's kind of one of the things I learned. To reverse the malware, we are going to use throughout this presentation this assembler, which is known as R2. Are there people in the room who know Radar 2 or have already used Radar 2? Yeah, one, not that many. Gidra, perhaps a little bit better, a little bit more. Okay. So actually, in terms of decompilers and disassemblers, Gidra is a little bit better known, but it is far more recent. The other one is nearly 20 years old. It's really usable professionally because it can support many different architectures, many different binary formats, things like that. The look and feel is a little bit surprising. You'll have the surprise because I have a few demos. It feels like, well, if you've already used VI, it feels a little bit like VI because you have a lot of crypted commands. But the good thing is that it's very scriptable. And yeah, the screen went off. There we go. That's no problem. Okay, so I'm going to use r2ai. And r2ai, as the name goes, it's a plugin for R2, so plugin for our disassembler. And AI means that we are going to have Radar 2 get some assistance from the AI. I'm just highlighting there that it's assistance with the AI. Do not expect the AI to do everything for you. It won't work that way. It's really like you've got to guide the AI if you want some interesting input as a return. It's implemented in a way which is pretty cool in the sense that it is not tied to a specific LLM. Sorry, it might not be clear. R2ai here is an open source tool that I am using, but I am not a developer of r2ai. It's not like my tool. It's just something that I use, and I'm going to show how to use it to use malware. Okay, so it's not tied to a given LLM. If you want to use it with GPT, you can. If you want to use it with Anthropic Claude, you can. If you want to use it with Mistral, you can. whatever. And actually, I presented this like 2 weeks ago at another conference, and I had to update the slide because in 2 weeks it's changed. Okay. This one has been out like on June the 25th, something like that. And it works straight away with r2ai as long as the API hasn't changed too much. Most of the time it works straight away and you can use the modal. So when we have a malware and we want to do something about it and to get some assistance from AI, we have two different modes with r2ai, the direct mode and the automatic mode. Gonna use a case as an example. So it's a little bit like shellcode. Okay, if you were at the talks a little bit before lunch about shellcode, this is a malicious shellcode which is used on compromised Linux hosts. And we want to reverse that one. And the good thing about it is that it's very small. Okay, it's a few kilobytes. And in terms of reversing, the smaller it is, the quicker you get into reversing. So normally it should be fine. Except that in this particular case, well, this one is a little bit hard because as you see, if you have a look at all the strings that you have, well, I mean, Norwegian isn't better for me, but this isn't really helpful, okay? And then when you upload it in Ghidra and ask it to decompile stuff, well, this is supposed to look like normal C code. And I think you'll agree that it's really not very understandable that way. If you have any experience in reverse engineering, you might notice the line, this one, no, I'm not going to play with the mouse, but the line SWI software interrupt is probably going to give you a clue about what is happening afterwards. Okay. So in the direct mode, what happens is that you are just sending a single request to the artificial intelligence and you get some answer back. Like all the time, you send a context, and in that context, well, you said plenty of things. r2ai pre-fills some things, and this is supposed to help us reverse this malware to get something better than what we have with Ghidra and understand better what is happening. And this is where I'm going to try and do a live demo. Now, the difficult part of it is to switch. Yeah. The difficult part is that I don't see that on my own stuff. Okay. So we're gonna load the sample, and the sample is yeah, shellcode elf. So this is R2. And I told you there were kind of cryptic commands. AAA means analyze all and do all your preliminary stuff. Okay, it does that. And then I'm going to list the functions. And there is only one, fortunately. I told you it was a really small shellcode. And we're going to decompile it. And you get that. And it's a little bit like Ghidra. Honestly, it's not that clear, okay? Unless you are used to reverse engineering, because there are no calls to functions in there to help you out about what is happening, okay? So now we're gonna ask the artificial intelligence for some help. So -H to get all the commands that you can have. And now I'm going to say that I am going to use this one. And now I've got to specify the modal, model, code straw, latest, yeah. And now I'm going to tell it -D is to decompile the current function. Okay. So it's the funny part of it is that I never get, of course, exactly the same answer. So each time I do the live demo, I have a few surprises. Okay. The naming here with this particular model isn't that good because it's still using registers, and in normal C code, you wouldn't use like variables named EAX or something like that. The good thing is that you see like socket calls here, okay, which is pretty good. I'm gonna try shortly to improve that a little bit. No. It's r2ai. AI. I. So this is the default prompt, and I'm going to do something like better. Decompile the function. Do not use register names as variables, but something meaningful. I want readable C code. Good dev would. Right, yeah, it's a bit long. Okay, sorry. And we are going to try that again, and hopefully it will be a little bit better. So you get lots of text. It's always wordy, but it is indeed better. Okay. I think this is starting to be a little bit more readable. We see that, well, obviously there is a socket which is created. It goes here to an IP address. We'll check this a little bit afterwards because it's kind of a little bit strange. It goes there, connects there. It's changing the memory. Yeah, the permissions for this area, reading data and subscribing. Okay, we'll go back to the slides. Okay. Wow. So, it's a little bit like in our first talk where he said, do not assume anything, do not guess anything. When you're a malware analyst and you get help from the AI, do not assume that the AI is saying something which is true. Okay, you've got to check it. So for instance, whatever is going to matter to you, we see here, for instance, that it is using many sockets, but we didn't see any calls in the disassembly to sockets. So this is kind of a bit strange, and we've got to be sure it's not a hallucination. So we see that this is generated by the AI. Actually, it comes out from this assembly code, which is there. And those 3 lines are actually indeed performing a call to socket because it is the interruption, software interruption AT here is performing a system call. And then which system call is put in the register EAX, and it's going to be the number 66, and number 66 is socket call. And it's a bit more complicated in that case because socket call is actually a multiplexer for several different socket-related calls. So here, depending on the first argument here, it's going to go either to sockets, to bind, to connect, to listen, or to accept. Now we're going to see that in detail. So this is the assembly. When we are doing an XOR between EBX and EBX, this is the classical trick actually to put 0 in EBX. Then we multiply EBX by, anyway, EBX is 0. So we're going to have in EAX, which handles the result, 0. Then we push on the stack EBX, so we're pushing 0. We increment EBX, so we have 1 in there. We're pushing that. We're going to push 1 on the stack. We push 2 on the stack, and then we put 66 in EAX. Then we put put the stack in ECX. and we do the software interrupt. When we have the software interrupt, we see that we have 66. So this is going to do the multiplexer socket call. The first argument of this socket call is an EBX1. If you remember from previous call, it means that it's going to call socket. And the arguments for socket are in ECX. So we have AFINet, SockStream, TCP. So in this case, the AI was perfectly right. And we checked it, but everything is fine. Now, another case here, I told you it's a bit strange in my opinion, in my experience, when we have a malware which is contacting something which is local. This is the local host address. It's possible, but it's suspicious for me. So I checked the assembly, the corresponding assembly is here. And if you map this assembly, okay, to the C structure, which corresponds there, well, you see you're gonna have AFINet, but you have 23 is here, 23.6b there, okay? This is going to be the port, so it's not port 80, but port 27,427. And same, the IP address is not the local host port, but this remote IP address. So actually, the AI was wrong. We are not contacting something which is local. We are contacting a remote website, which makes much more sense, actually. We go a little bit faster on the next ones, okay? But again, we have to check everything it says here. It is setting the protection, and it's saying it's for this address. Well, not really. If you check the assembly, it's setting those permissions for the stack. And here, when it's reading something from actually, it's not reading from 0, it's reading from the socket. So the input socket is sending it stuff. And then another typical error that we see very often in AI is that it omits things. Sometimes it thinks that things are details and it says, okay, I'm not going to talk about it. But the fact that the issue is that what is details for it isn't always details for you, okay? And here, so what we have is pretty important is that here we're setting the stack as readable, writable, and executable. Then in the socket, the remote end is writing a payload on the stack. And then the AI completely forgot the last step, which is executing what has been sent. If you're not executing it, that's kind of a bit strange, but it will be useless. But that is not a detail, of course. So if we recap, we have an infected host, okay? We create a socket to the remote end. It sends a malicious payload, and it executes it. So we got this with the help of the AI, but we had to check a couple of things from that because everything wasn't totally correct. Now, the automatic mode. The automatic mode, in my humble opinion, well, okay. The automatic mode is even more powerful because you are telling the AI, hey, I have tools that you can use. And for instance, it's just like if you were telling the AI, hey, I've got a screwdriver. And if you want to use in your stuff, if you need a screwdriver, I can lend you a screwdriver. So here we're going to tell it, well, actually, for instance, okay, decompile this malware. But if it's useful for you, well, I have Radar 2 installed on my host, and you can send me commands for that to help you with the disassembly. The AI will say, okay, well, locate for me then the entry point, and the command is IE. R2ai is going to say to the end user, are you okay if I run IE on your host? And you decide or not. In the end, if you decide yes, then IE will return the entry point address, and we'll send that back to the AI. And then it continues until the AI may have like many other questions till the end, until it is able to solve your question. It can do many other things, actually, not only execute radar commands, it can also execute JavaScript programs, Python programs, and everything. The only big issue there is that it's running on your host. So you've got to check what the AI sends you to be sure that it's not going to be harmful one way or another for you. So I'm going to show you again another demo, but this one is recorded, where it should be like a little bit easier to show. On another malware, Ladvix. Okay, it's more complicated. This one, it's bigger and everything. We're not going to do everything about it, but we noticed that there are obfuscated strings like this one. And we know also that the function that deobfuscates it all is this one. So we're going to ask r2ai to do the deobfuscation for us. Yeah. There we go. I'm gonna clear that and play there we go. So we're loading R2 on our sample, Ladvix. Same thing, we're gonna do the AAA thing. List functions, there are far more, okay. But we're going to disassemble. And here, well, it's up there and my font is a bit big, but we have here the deobfuscation function, okay? And I'm going to locate all places in the main which are using the deobfuscation function. This is this command there. We see it's used in several places, and I'm going to disassemble, sorry. For instance, this place. And before. So yeah, I did it the other way around. So you see here the obfuscated string here, and then after that, the code goes up there and it calls the deobfuscation function. Now we configure r2ai to use our favorite model. In this particular case, I get very good results with Claude Sonnet. And we are going to trigger the automatic mode with -a. And then we have our question, and we're basically going to tell the AI, hey, I have some obfuscated strings. Can you do my work while I go to sleep and deobfuscate them for me? I'm joking. Most of the time, you can never go to sleep because you just have like to hold its hand all the time, like, you know. It's nearly done. So you can send some input like to the thing. And then you see actually the AI doing its work. So for instance, it tells us, okay, let me examine first the obfuscation function. Then here it is trying to locate the obfuscated string. And actually it struggled, which is quite amusing because it didn't do it the right way. So, but you see it's going to improve itself. Eventually it will actually get it. And this is the correct command. And here, this is the obfuscated string. And now, so we let it do a little bit of its work. So you see, hey, here it is sending R2 commands to us. And then it builds a script, a JavaScript to deobfuscate the string. And I just have to review that and change a little bit if I wish, and accept to run that or not. And there you go. Can you see it? This is the deobfuscated string. So it is actually touching in the cron tab. And there we go, back here, sorry. And I've nearly finished. This is done. For Prometei, we don't have much time, but basically what is important there, if you have packed malware, well, decompilers don't know how to handle packed malware. You always have to provide them unpacked things first. And it's the same with AI. If you send to the AI a packed sample, it won't be able to process it. Please, well, first, if you want to get some answer, first unpack it and then tell the AI to run on that. And that's basically the takeaway. Well, it will save you time, but please do check everything that the AI says that matters to you, and do remember that the AI is an excellent storyteller. So it will kind of convince you that something is true. You should really pick on facts and make sure it is really true if you don't want to make a fool of yourself, okay? And the other thing also is that if you try just like for 2 minutes the AI and it's not giving you a good output, do not let go immediately. You've got to persist a little bit, try again, improve your prompt. It's a little bit like if you have a smart intern in front of you. Your intern is not going to give you just like sparkling great results immediately. You'll probably have to guide your intern a little bit to get the good results. It will happen, but you need a little bit more time. And that's all. Thank you very much for your attention everywhere. And I'd say, yeah, so the maintainer and the creator of R2 is this one, Sergi Alvarez, and Danielle is one of the main contributors to r2ai. So those are the ones who build the tool that I can use to reverse the malware.
Thank you very much. Are there any questions? Stun them all into silence. Do you think AI is going to change the face of cybersecurity?
I don't know, but I'm lucky actually I didn't have like somebody tell or an AI in the audience asking me a question like, you know.
Okay. Sorry.
Question.
Yes.
Yeah, so Radar 2, but have you talked to Binary Ninja or Ghidra or any of these? Are they developing their own competitor for this to?
They are. So Ghidra is has a plugin which is called Ghidra MCP, a Modex Control Protocol, which is working also quite fine. But there are a couple of other issues with it. Is that you cannot control the same way the commands which are sent to your host. You don't have the fine grain possibility to see exactly what is going to be run on your host. So this can be dangerous when you're analyzing malware, okay? And IDA Pro, same thing. You also have some MCP stuff which are being developed. For Binary Ninja, I'm not sure. I don't know.
Thank you. Thank you very much.
You're welcome.
Final round of applause.